Hi, so today we are solving equations that either by using a trig identity or some that involve a trig identity to, we're using trig identities to solve equations. Okay, so the first thing we're going to do is we're going to practice writing trig expressions in factored form. So if it looks like this, you might think of that trig identity, the cosine squared, as just a different variable. So the cosine is a function. So the cosine of x squared in this case is the same as saying anything squared. So I'm going to pick a different variable. We're going to say it's m squared, and then we have plus 2m plus 1. So if we think of taking out the cosine and replacing with an m, this is just a trinomial that we've factored many, many times. So m plus 1, m plus 1, or m plus 1 squared. So that's how that trinomial would factor. This, when I plug the cosine back into this final answer, it looks like the cosine of x plus 1, the cosine of x plus 1, or the cosine of x plus 1 squared would be that trinomial trigonometric expression in factored form. So let me erase it and put it over here. Sometimes you'll have to use a trigonometric identity before you can factor. So let me show you one like that. So this expression, trinomial expression, has both a cosine and a sine. You can't factor like we did over here if we have two different functions in that expression. So we need to switch one out for the other. So I either need to turn this basic cosine into a sine, or I need to turn this sine squared into a cosine. I know that I have an identity, cosine squared plus sine squared equaling 1, or I could rewrite it as sine squared equaling 1 minus cosine squared. So this is what I'm going to use right here. I'm going to replace this sine squared with a 1 minus cosine squared. Like so. So that, again, is just taking out the sine squared and replacing it with a 1 minus cosine squared using this Pythagorean identity here. So the cosine of x minus 2 plus 1 all stays the same. So if I distribute this minus 2 here, I have cosine x minus 2 plus 2 cosine squared x plus 1. And rewriting it in a kind of descending order here, it looks like that. Okay, so now back to our what happens if I replace the cosine squared with an m. I have 2m squared plus m minus 1. And how does that factor? 2m and an m, a 1 and a 1. I need a positive 1 in the middle. And a negative 1 at the end. So this would make 2m squared plus 2m minus 1m minus 1. So that's how that would factor. And so this, when I put that over here, it looks like 2 cosine minus 1 and then cosine plus 1. So again, you could double check your math to see if you factored this correctly. If you used your FOIL method to multiply it out, 2 cosine times cosine makes the 2 cosine squared. Here I would get a positive 2 cosine, a minus 1 cosine. That cancels to make a positive 1 cosine, and then a 1 and a negative 1 multiplies to make negative 1. So this is your factored form for this one. If you're being asked to simplify, like so, the top factors to a 1 plus sign, 1 minus sign. So how does that work? 1 times 1 makes your 1. Out here, you'd get a negative sine x, and in here, you'd get a positive sine x, which would cancel each other out. And then a sine times a sine makes the sine squared. And then I can cancel this 1 plus sign on the top with this 1 plus sign on the bottom. That's the same as saying 5 times 4 over 5 is equal to 4. The 5's here can cancel. The 2 on the top are multiplied, right? So this number multiplies by that number, divides by the same thing. Those two can cancel. The same way the 5's could cancel here. The hardest thing about trigonometry really is algebra. And so this simplifies to 1 minus sine. Okay, so if you're asked to solve an equation, so you always want to make sure your equation is equal to 0. When we're solving this equation, let's see, it was 2m plus 1 equals 0, right? If I'm solving this equation and I factor it to m plus 1, or m plus 1 squared, then I would solve this and get m equal to -1, right? I would solve by setting the factor equal to 0. And if I had two different factors, I would set them each equal to 0 to solve. This is the same idea. This example that I have written here, though, is not going to factor the way this factored into two sets of parentheses. There's not 3 terms. It's not a quadratic trinomial. There's not a squaring to factor into two sets of parentheses or whatever. So what you're going to do is you're going to look at, see how there's 2 terms here, and they both have a cosine. So we're going to factor that cosine out, leaving me with 2 sine x minus 1. So again, double check. If I multiply the cosine into this expression, 2 times cosine times 2 sine x makes 2 cosine sine, and then cosine times 1 makes cosine. And then I'm going to set each of these equal to 0. So cosine equals 0, 2 sine x minus 1 equals 0, and then you solve each of those little equations. So over here, I would add the 1 divided by 2, and I'm looking for where the sine is equal to 1/2. Here I'm looking for the cosine is equal to 0. So 2 ways to do this. I'm looking for, let's do this one first. This is similar to what we've done in the past, where there could be 2 different answers. The sine is opposite over hypotenuse. So 1 over 2, 1 over 2, 1 over 2, 1 over 2. The bottom 2 triangles don't work because those ones would be negative, right? So this triangle doesn't work and this triangle doesn't work. So what is the angle in here that would give me 1/2 for a sine? So this is a square root of 3 right here. So this angle would be 30 degrees. Pi over 6 right here. And then this one over here, if the reference angle is 30, the angle is 150, or 5 pi over 6. You will be looking for the radian measure. not the degrees. The question will say in the interval 0 to 2 pi. So what about the cosine of 0? The cosine of 0 means that our triangle has 0 for the adjacent side and something for the hypotenuse. So we're looking for the two triangles that have 0. Sorry, we don't need all four for this one. 0 for the adjacent side, 1 or something for the hypotenuse, and then whatever goes here would be a 1 as well, right? So x is 0 and y is 1, or x is 0 and y is -1. Those are the 2 points, one up here and one down here. So my x would be 90 degrees and 270. For this particular problem, we have 4 answers. 2 for this part of the equation, 2 for that part of the equation. The other way to do this without triangles is to use your unit circle. For the first one, we'd be looking for where the sine is equal to 1/2, and the sine is the y value. So the sine is 1/2 in this ordered pair, the sine is 1/2 in this ordered pair. Here we have a -1/2, so that doesn't work. Here we have a -1/2, so that doesn't work. So our two answers would be pi/6 and 5pi/6, those two angles right there. For x equaling 0, so for this one, you would be looking for a 1/2 for your y in the ordered pair. And for this one, you'd be looking for a 0 in the x ordered pair, like we talked about a second ago. And so here you have a 0, 1 and a 0, -1. There is a copy posted on Canvas as well of the unit circle. If you don't have one that's filled out, you can find one online pretty easily as well. Okay. Okay, so this one says the tangent squared of x is equal to 3. Now this is one where we're not going to make it equal to 0 first. And this one I talked about making sure it was equal to 0 at first. This one has a different set of rules because it's a single term right here all by itself. So, and since it's the x tangent of x squared, I can take the square root of both sides like so. And on the left side, the square root and the square cancel, and I'm left with the tangent. And on the right side, I have the square root of 3. And what I have to make sure of when I put a square root into an equation is that along with it, I put a plus or minus. So now I'm looking for where the tangent is equal to the plus or minus the square root of 3. So if I was using my triangles, again, I have 1 in each quadrant. Tangent is opposite over adjacent. So think of this as the square root of 3 over 1. And I can also have the negative square root of 3 over 1. So opposite side would be square root of 3, adjacent side would be 1. Opposite side would be the square root of 3, adjacent side would be -1. Opposite side would be negative square root of 3, -1, negative square root of 3, +1. So the only one that, or they all four work, I'm sorry, they all four work. So the angle that's in here is 60 degrees, right? Which means my answer for this one, 60 degrees is equal to pi over 3. So pi over 3 is one of my answers. For this one, 120 is 2 pi over 3. This one, 240, sorry, is 4 pi over 3. And 300 is 5 pi over 3. So 5 times 60, 4 times 60, 2 times 60. So my 4 answers look like that. If it says to solve for all of, or find all of the solutions, you are going to just solve for the 0 to 2 pi interval. We're not going to worry about the general form of the solution. So all right, so this one, 4 cosine squared minus 4 cosine plus 1 equals 0 factors to 2 cosine plus 1. Oh, sorry, minus 1. And then 2 cosine minus 1. So double check that you are factored correctly. 2 cosine times 2 cosine is 4 cosine squared. Then a minus 2 cosine and a minus 2 cosine makes your minus 4. And then negative 1 and negative 1 makes positive 1. So since we have just one, basically, right, we're just looking for where that's equal to 0. So where does 2 cosine minus 1 equal 0? So it equals it at cosine equaling 1, positive 1/2. So again, if you use your triangles, you'd be looking for where the adjacent side is a 1 and the opposite side where the hypotenuse is a 2. So here's a negative 1, negative 1, 2, positive 1, 2, positive 1, 2. So you're going to use these two triangles on the right. The two triangles on the left have negative 1s, so they don't work. This angle right here is a 60-degree angle, so pi over 3. And then we talked about this one already. This is 300 degrees, which is 5 pi over 3. Again, if you were using your unit circle, you'd be looking for where the cosine, which is your x value or your x coordinate, is 1/2. And so same idea. We have a 1/2 here and a 1/2, or sorry, there's 1/2 and there's one there. Why can I not see what I'm doing here? There, sorry, quadrant 1 and quadrant 4. Okay, pi over 3, pi over 3. Okay, so those are all posted in Canvas for you.